Okay, in this section we're going to look at some applications involving annuities. An annuity is an investment that involves regularly scheduled deposits over the lifetime of the investment. So you saw in simple interest and compound interest, we just had an initial amount and we didn't add anything, we didn't take anything out, we just took all the interest and added that up. Well, not all accounts work that way. Sometimes you want to put amounts in deposits over a regular period of time. So for the accumulated value of an annuity, we have a periodic payment, capital P, and it's deposited N times per year at an annual interest rate R with an interest compounded N times per year for a period of T years. And here is our big equation. Our accumulated value is equal to the periodic payments, so how much you're putting in over a period of time, over a value of R, and R is equal to that ratio of our interest rate over the number of times that it's compounded. Now that's being multiplied by 1 plus that ratio of R over N raised to the N times T power minus 1. This A value, this accumulated value, is also known as the future value of your investment. So if you take any business courses, you're going to see these types of equations show up when you're trying to figure out what's the future value of my investment to see if it's worthwhile. So here's an example. We have Rachel, and when she was a kid, her parents opened a college savings account, and they were saving $200 each month at 5% annually and is compounded monthly. If the account is currently worth $30,000, how long has the account been opened? Well, let's take a look at what we have. So we have our periodic payment of $200 per month. We have our interest rate at 5%, so that's 0.05. N is 12 compounds because we're compounding monthly. The accumulated value is $30,000, and we're trying to figure out how long has that account been accumulating. Well, let's figure out our ratio. So our capital R is equal to our interest rate, so our 5% over 12, and that's going to equal 0.00416 repeating. We'll place that inside our equation. So we have 30,000 is equal to, oops, don't need our bracket yet, our periodic payments are a deposit over our ratio. Now we're going to multiply that by 1 plus our ratio raised to the 12 times T power minus 1. Okay, and let's simplify. We're going to multiply by the reciprocal of our ratio, and that gives us 0.625, and that is equal to 1.00416 to the 12 T power minus 1. Okay, we're going to add 1 to both sides. Okay, and we are trying to solve for t, and t is part of our exponent, so we need to take the natural log of both sides. And if we end up rewriting that, we end up with the natural log of 1.625 is equal to 12t times the natural log of 1.00416. So to solve for t, we're going to divide both sides by 12 times that natural log. And we end up with our answer of T is approximately equal to 9.73 years. So they've had that account open for her for almost 10 years.